Norton's theorem is used to solve complex electric circuits consisting of several energy sources and impedances by converting them into a simple equivalent circuit called a Norton's equivalent circuit. So here you can see there is an electric circuit which consists of a voltage source and many impedances connected across the load. Now this can be converted into this equivalent circuit that is called as a Norton's equivalent circuit, where the current and voltage source given in the electrical circuit can be replaced with a single current source, and similarly all the impedances can be replaced with a single equivalent impedances connected across the load, right? So here Zn stands for the Norton's resistance or Norton's impedance, and In stands for the Norton's current, right? So how to solve a circuit using Norton's theorem? So this circuit can be used to solve both the AC and DC circuits. So here to solve the Norton's theorem, there are three steps involved. So the first step is to find the value of In, right? Let this be the given circuit. So in this circuit there is an voltage source and there are three impedances and there is a load impedance. Okay. So in order to find the value of this Norton current, we have to remove the load resistor or the load impedance and short the terminals with a wire. So this is the resultant circuit. So here the load resistance has been removed and the terminals are shorted with a wire. Okay. So now we have to determine the current flowing through this path AB, which gives the value of the Norton's current. So this is the first step. Then the second step is to find the value of Zn, that is Norton's impedance or Norton's resistance. So in the given circuit, here we have to remove the load resistor, and if there is an voltage source, it should be replaced with a short wire, and if it is a current source, it is to be removed and kept it open. So here in this circuit, this is redrawn by following these steps as like this. So here there is a load impedance, it is removed, and here there is a voltage source and that is removed and it is shorted. So this is the circuit. So in this circuit you have to find out the value of the Norton's impedance or Norton's resistance across the points A and B. Once the value of current and the value of the impedance are known, the next step is to draw the Norton's equivalent circuit. So the Norton's equivalent circuit is drawn only with the help of In and Zn as like this. Both are in parallel, and this combination is connected across the load impedance. So using this circuit, it is easily possible to find out the value of load current, that is IL, or the voltage drop across the load. So let us look at the problem. So in this problem, a circuit is given and determine the current flowing through a 10 ohm resistor using Norton's theorem. So here is a 10 ohm resistor. So you have to find out the current flowing through this 10 ohm resistor. Okay, and there is a 9 volt source is given and there are some internal resistances, right? So how to solve this? You have to follow the three steps which explained before. So the first step is to find the In or the Norton current. So this is the given circuit, and in this circuit 10 ohm is a load resistor, and to find out the Norton's current, remove this load resistor and short the terminals. So you get the circuit like this. So here the load resistor is removed and it is shorted. So now we have to find out the current flowing through this path AB, that is nothing but the Norton's current. So the current through the path AB is nothing but the current through the 2 ohm resistor, which is the same path, right? So we have to determine the current through this 2 ohm resistor. So if you observe the circuit, this 3 ohm and 2 ohm are in parallel, right? And here there is an voltage source, and Here the current from the source will come here, and from this place it has two paths, right? Two parallel paths. So we can able to determine the current flowing through this 2 ohm resistor by using the current division rule. So in order to find out the current division rule, we need to know the total current flowing from the supply. So to find out the total current, we have the voltage and we have the internal resistances. So find out the equivalent resistance first. So here to find out the equivalent resistance, again if you observe the circuit, this 2 and 3 ohm are in parallel, and this parallel combination is connected in series with this 1 ohm resistor. So the equivalent resistance can be easily obtained as like this, that is 1 plus, and this 2 ohm and 3 ohm are in parallel. So 3 into 2 divided by 3 plus 2 gives the equivalent resistance. So once the equivalent resistance is known, we already know the voltage. So by Ohm's law, we can able to find out the total current. I is equal to V by R. V is nothing but the 9 ohm and R is nothing but 2.2, which gives the total current as 4.09 ampere. So now we have find out the total current flowing from the supply. So the current flowing from this 9 ohm resistor has two paths. One is through the 3 ohm resistor and the other is to the 2 ohm resistor. So by applying the current division rule, we can able to find out the Norton's current or current through the 2 ohm resistor. So how to apply the current division rule? The current through the 2 ohm resistor is equal to the total current flowing from the supply multiplied by this two branch, the parallel branch, right? You have to consider the parallel branch alone. So total current multiplied by the opposite branch resistance divided by this total branch resistance. So if we apply that, we get the value of the Norton's current. So see here, this is what we have written. And the second one is to find out the Norton's resistance. So to find out the Norton's resistance, consider the given circuit. So in the given circuit, here there is a load resistor. We have to remove this load resistor and we have the voltage source. We have to remove this voltage source and the terminals should be shorted. So the redrawn circuit will look like this. Okay. And here we have to find out the Norton's resistance. So if you observe the circuit, here 1 ohm and 3 ohm are in parallel, and this parallel combination is connected in series with this 2 ohm resistor. So easily we can write out the Norton's resistance as 2 plus 1 into 3 divided by 1 plus 3 gives 2.75 ohm. So we have got the Norton's resistance. Now the third step is to find the Norton's equivalent circuit. So we have obtained the value of the Norton's current and Norton's resistance. Simply draw the circuit. So the Norton's current source is drawn parallel to the Norton's resistance, and this combination is connected across the given load. Okay. So now the question is to find out the current through the load. So we have to determine the current through this path. So here this is the total current, and here this current has two parallel paths. So apply current division rule. So if you apply the current division rule, we get the total current into the opposite branch resistance divided by the total branch resistance gives the value of current flowing through this path. So write the formula and substitute the values and you get the answer. We can have a look at another problem here. Determine the current through AB in the given circuit using Norton's theorem. So here AB is given as like this. So 6 ohm resistance. So we have to find out the current through the 6 ohm resistance. So this 6 ohm is considered as the load for this problem. Okay. And here there is a current source and there is many internal resistances are given. Right. So to solve this, first we have to go to the first step to find the Norton's current. So consider the given circuit, and here this is the load resistance, and remove this load resistance and short it with a wire. Okay, so now we have to find out the current through the path AB. In this circuit, we need to find the current IN through the path AB. So since the path AB has low resistance, maximum current will flow through this path. Okay, so it has nil resistance. This is a shorted path which has low resistance. So the maximum current will flow through this path. Hence, the circuit can be redrawn as like this, a very simple circuit. All the remaining parts can be omitted because comparatively this has the low resistance, so the maximum current flow through this path. So now we can directly write IN, the Norton's current IN is equal to 30 ampere, because this is a series circuit now. So this 30 ampere source, the current from the 30 ampere source will flow through this path. So IN is equal to 30 ampere. Then the next step is to find RN. So to find the RN, remove the load resistor. 6 ohm is the load resistor. Remove the load resistor, and we have the current source. So remove the current source. So here is the current source. Remove the current source and redraw the circuit. So if we redraw, we get the circuit like this. Now when you observe this circuit, there will not be any current flow through 10 ohm resistor as it is open. Also 3 ohm and 1 ohm are in parallel, right? These two are in parallel. So we can draw the circuit like this. So here it is a 4 ohm and this 10 ohm is removed. Okay, there is no use in keeping this 10 ohm resistor, so it is removed. And here the 3 ohm and 1 ohm are in parallel, so it is written like this, right? The equivalent resistance is obtained. Now this and 2 ohm are in series. Okay, these two are in series, and this series is in parallel with this 4 ohm resistor. So this is again redrawn like this. So 4 ohm resistor is parallel with this 2 plus 0.75, 2.75, right? 4 and 2.75 both are in parallel. Now the total resistance can be obtained. Since these are parallel, the equivalent resistance can be obtained as like this: 4 into 2.75 divided by 4 plus 2.75, which gives 1.63 ohm. So this is the Norton's resistance. Once it is determined, next is to draw the Norton's equivalent circuit. So Norton's equivalent circuit, we know the current, we know the resistance. Both are drawn parallel. Okay, both are connected in parallel, and this parallel combination is connected across the load. So again, to find out the load current, apply the current division rule. So the current division rule, the total current into the opposite branch resistance divided by the total branch resistances. So if you substitute the values, you get the value of the load current. Okay, so this is how we have to solve the circuit using the Norton's theorem.